All righty. First off, I'd like to give a thank you out to Mr. Murphy. He let me borrow his iPad today so that I can instruct you wonderful children. Because we got some stuff to go over and we're gonna start something kind of new today, a little bit confusing, kind of like some of the other stuff we've done, but don't worry, when you get back in school, we're gonna do a big review on all this stuff because I guarantee you, I know some of you think you know it, but when I put you and I give you a test, you're gonna really start wondering, wow, maybe I don't know this. So real quickly, we're gonna go over a couple of cloud concepts and a couple of other things that I've taught you before, but I don't know if you've remembered or not. So real quickly, I want you to write down the cloud that is vertically grows. It's a vertical growth group cloud, but it means fair weather is gonna occur that day. Okay, which one would that be? And I guarantee you, some of you are not gonna get it because some of you guys are not doing the lessons. Where are y'all's whiteboards? Are y'all gonna hold up some answers? It's a what? A cumulus cloud. It's a cumulus cloud. Good job, man. If you got that correct, you are doing awesome. All right. Now, I want you to write down a low-level cloud that means rain for many, many days, and it's all gray in color. Which one is that? It's easy to get these two confused, but I think you can do it. You guys got it? Oh, Maiden Michael, not quite. That is a thunderstorm cloud, which this low-level cloud would be a stratus cloud. And it's in the...
I was about to put that down, but then I was about to change it.
Well, girl, always go with what your gut tells you. I think that's usually the best thing you can do when you're learning all this stuff. If your brain sits there and says, I think it's this answer, it's probably most of the time that answer. That's usually what I've kind of figured out through my years is when kids are like, oh, I should have answered that. 65, 70% of the time, they're usually right. So just try to always remember that. All right, got a couple more questions for you. This cloud is mainly made of ice, and it's really in the high cloud group. In fact, it's got one of the prefixes for our clouds. And you can see through these clouds, and they're feathery, and their nicknames are mare's tails. Which one's this? If you got Cirrus, then you are correct, boys and girls. All right, we're gonna move on. I'm gonna ask you some other questions. Now, what if I was to look at a globe? You know, a globe looks like the land and the water that we live on. What two things would I see the most of? If I looked at a globe, what two items would I look at mainly the entire time? It should be really easy. I hope we're not. Clouds, good Lord. Haley, clouds? If I looked at a globe, wouldn't I see water and land?
Yeah.
Land and water. You probably see some clouds too, Haley, but remember the clouds are above the land. But still, you would see some clouds, which, remember, Haley, clouds are water. So that's something for you to think about too, is clouds are water. So basically, you kind of wrote down water. All right, now, which one heats up quicker? Is it land or is it water? Which one's gonna heat up quicker, land or water? Okay, let's write that down real quick. Has anybody got it? Oh, Aiden, Michael, water. Yeah, if it's a small little, if it's a really shallow puddle, Aiden, it probably will heat up quicker. But water generally takes a lot longer to heat up. Okay, and we're going to talk about that today because we're going to start talking about wind today. And wind is kind of a tricky thing. But I've kind of taught you some of the things you need to know. But before we get started with that, I want to go through some of these slides that I had for you yesterday, but I couldn't upload my lesson because my iPad was messed up. So today I'm going to show them to you because they're really good pictures. So real quickly, that's condensation. Obviously, we've gone over that quite a few times. Let me go down here to my clouds.
Wow.
So real quickly, I just want to go through a couple of these real quick. Can y'all see that? Okay, is that cool? Y'all can see that all right?
Yeah.
Okay, cool. All right, so I'm just gonna go through these. You guys kind of relax. I am not gonna ask you any questions on these clouds. I just want to kind of go through them because they're kind of cool. So these guys right here, you can see that jet, and you can see the condensation trail coming out of the back of that jet. Well, that can be a cloud. You can see right here on this right picture, those like breadsticks through the sky. Those are from jets, and they are called contrails. Some people call them chemical trails because they think they're a bunch of chemicals coming out and getting into our atmosphere, and they're messing up the environment. It could be true. I'm not really sure, but it's definitely condensation. It's a cloud. So those can join weather systems. Really cool to think about, that they can, something that's man-made can join a weather system. Really neat, in my opinion. Maybe not y'all's opinion, but that's okay. We all have our opinions. So I want to talk to you about these clouds real quick. These are, well, it won't let me do it. These are called mammatus clouds, and these are the sign that really massive thunderstorms are coming in your area. We don't really get these clouds here. They're more of something like you would see if you lived in Oklahoma or Kansas or Missouri, Nebraska. These are generally right before a tornado is gonna strike, okay? So they're really dangerous clouds.
I think you got to mute your.
You gotta mute your thing, man. All right, now, we talked yesterday about cumulus clouds, okay? Now, these are a picture of cumulus clouds. You've probably seen these clouds a great deal. They look like big balls of cotton, basically, with a dark bottom. And that dark bottom is because of the shadow that the cloud is casting on the bottom of the cloud. These are cumulus clouds. These usually mean a fair day. They can occasionally grow into thunderheads like these clouds I'm about to show you, but it's very rare. Generally, these mean you're gonna have a great day. It's gonna be sunny pretty much all the time. Now, this next cloud, this right here is a cumulonimbus cloud. And if you are interested today, it is a great day to try to go outside and look at the clouds, because there's a system moving through. It's a cold front is moving through right now, and we're gonna get some thunderstorms. And if you go outside and look around every few minutes, especially if the sun starts shining, you guys should go outside, because there's bound to be some cumulonimbus clouds somewhere over the ocean. There's gotta be, because they were all over the place this morning when I came to school. Here's another one. Now that looks like a bomb went off, doesn't it? It looks like a bomb, like from a cartoon bomb. Well, that's actually a gigantic thunderstorm. I don't know really where, but you can see the bottom is super dark. Now, one thing I do want you to notice is something's going on here that I've kind of taught you guys. And the top, do you see how it's kind of flat at the top? Well, the top of that cloud has hit the top of the troposphere, that part of the atmosphere that we live in. And then you see this little itty bitty part right here. That is the part that has gone up into the stratosphere. So there are a few clouds in the stratosphere, not too many, but you can see it's kind of almost like an invisible force field around us. Clouds have a really hard time getting through it, and that's why things can burn up in our atmosphere, like, asteroids and stuff. I got a couple more pictures. Here's another one that has hit the top of our troposphere right here. You can see it's kind of like it's hit it, and it just does nothing but gets reflected, I guess you could say. But these are huge thunderstorms, okay? Huge ones. Here's another picture of some. That might be it. Okay, now, next we're gonna go over, and I'm giving you guys a quiz on all these clouds today, just so you know. I'm gonna throw a little bit of this wind in here. But before we get started, we're gonna, okay, so we're gonna talk about wind today. Now listen, does anybody have a question? Is everybody up? Are you guys paying attention? Okay. Because this is really important what I'm about to go over because it's going to go over a whole lot of questions. Wind is something we got to have on Earth. And we're going to always have it because wind is made by one thing. And what do you think that one thing is? It's always above you. Not water. You need water. What's the most important thing we got? The sun. Good, guys. Is that you, Haley, that said that? It's the sun. The sun makes all the wind. And we're going to talk about why in just a second. Now, when we live around here, do y'all notice the wind blows a lot? Give me a thumbs up if you think so. You guys notice the wind ever blowing? It blows all the time. That's because we live beside a body of water, which is the Atlantic Ocean. And I'm going to describe to you today why the wind's always blowing here, okay? Now, let's go over a few facts about the wind first, because this is really important. Uh-oh, hold on. Why is this not doing? All right. The main cause of the wind on Earth is the sun, okay? Now, that's the most important thing. We got to have the sun because the sun provides heat for us. And heat is what kind of gets this motor going to get the wind going. So when you look at a globe, which I have shown you a globe before, and we already talked about this, you see mainly land and water. Those are the two things that dominate the Earth. Water's about 75% of the Earth. We got about 25 to 30% of land, and it makes a recipe for us to get wind, okay? So when we look at this, we learned back a few weeks ago that land heats up faster than water. And why is that? Why does land heat up faster than water? Somebody raise their hand and tell me, why would land heat up quicker than water? And I already told you the answer. Really?
Is it because the sun hits it more?
It's not necessarily that it hits it more, but what can land not do? What can the land can't move? Good. The land is stationary, and when something stays stationary, just like if I plopped you out in the middle of the playground and said, "Don't you move, you're gonna let the sun bake you," would that make you hot? Yeah. Well, it does the same thing to the land. So what do we do when we get hot? We just go get underneath the shade of a tree. We go inside, we get in the air conditioning. But land doesn't have that luxury. Land gets beat down all day. And when land gets beat down all day, it starts to make a bunch of heat. Well, I'm going to show you what heat does. We've already talked about it. Another cool thing about land and water is this. When the sun goes down, guess what happens to all the heat on the land? Anybody want to tell me? Yasmin!
It gets cold?
It does. The heat from the land, because it doesn't have its heat source anymore, all the heat stops and all the heat rises up into the atmosphere and it just goes away. It gets lost up in the atmosphere. Very much like if you're not going to use the oven anymore, you turn it off and doesn't it cool down? I hope so. So it's very much the same principle, okay? So how does all this affect us in Wilmington? Well, let's talk about this real quick, all right? And I'm going to talk to you about how wind is made because this is really cool. And I'm going to explain to you because we are a wind factory living in this town right here. And anybody along the coast, I don't care if it's along the coast of Mexico, El Salvador, California, if you're living near a body of water, you have a perfect recipe for wind. And I'm going to tell you why. So you guys pay attention. So here is a slide. And can you guys see the mountains at the bottom? Can you guys see the mountains at the bottom? Give me a thumbs up. I think you should be able to. You can't see them? Okay, let me see. You can't see that, Yasmin? Well, it's close enough.
I can't see it.
Well, they're right here. So I'm going to draw them and outline them in black right here. And then I'm going to say that this right here is water. And here is the land. Okay? Can you guys see that? Can you give me a thumbs up?
I can only see land. I can't see anything else.
You can't see the water? Oh, man.
No.
All right. Well. second. I'll tell you what I'm gonna do. We're just gonna make it a little bit higher. Can you see that?
Yes.
All right, so there's the land. Let me use a different pencil. That one doesn't work so well. So here's the land, okay? And then this right here is gonna be our water, okay? Here's our water. Now, before we go on any farther, can anybody give me any kind of evidence, any kind of thing you've seen before with your eyes, not heard with your ears, you've seen it with your eyes, that would suggest to you that heat rises? Is there anything out there that would tell you that heat rises? What's something that you've looked at with your eye that could tell you that?
Clouds.
Huh? Clouds?
Cloud evaporation.
Okay. Warm vapor rises, but can you see evaporation, Aiden Michael? Can you see evaporation happening? What's something you've seen with your eye that could prove to you that heat rises? All right, how many of you guys have ever cooked before with your parents in the kitchen? You guys ever cooked before? All right, so let's say we got a pot of water on the stove and it begins to boil and you start seeing the white steam coming up. Where's the white steam going? Is it going down? Is it going to your feet? It's going up, right? Because it's hot. It's hot, it's going up, all right? Well, listen, that's kind of like how wind's made in a way, and we're going to talk about how. So when you are in the sun, okay, and here's the sun way up here. Can y'all see that red sun? Can y'all see that? I hope so, because if you can't, we might have to get your eyes checked. So this is what happens. So here we are, we got the water and we got the land. Well, we already talked about how land is standing still. It doesn't move. So it's just sitting there. It's not a moving target. Water's a moving target because water is going all up and down and around. You guys ever been to the beach and you seen the waves before? Is that water staying still? No, it's in constant motion. It's always moving. The currents of the ocean are always moving. Land is not. So what happens when something gets really, really hot? Well, it starts to heat up and heat starts to rise off of people. If you look at people, sometimes when I was a kid and I played football, I would take my helmet off and it was really cold outside and my head would be sweating and the steam would be going up because it was hot steam. So when the land gets hit by the sun, what do you think starts happening? What starts going up?
The heat.
The heat from the land. So the heat from the land starts to go upward. Okay, so it goes all the way up into the atmosphere. Okay, and I'm going to show you a real quick video of something that maybe you can understand what's going on. All right, so let's look. I think this is it. Here we go. All right, now I want you guys to watch this guy right here fly. Okay, now look. It's a big bird. This is a golden eagle, probably about 12-foot wingspan, huge bird. Okay, so this bird is flapping its wings very few times. Look at how it's just staying in the air and he's not even flapping his wings. We can see this a lot when you go outside and you're not going to see a golden eagle in Wilmington because they're not around here. They're in the Midwest. There's some I think are in South America, but you can go outside any day and you can see a buzzard flying just like this guy and he's not beating his wings. Well, why is he not beating his wings? Can anybody tell me why he doesn't have to really beat his wings that much? And I want you to think about it. Elijah, what do you think?
He's flying.
Well, yeah, he's flying.
His wings are so
Well, listen.
because his wings are so big, he can glide.
Okay.
He doesn't have to flap much.
That's definitely a part of it. His wings are big. They can catch a lot of wind. That's a great example. It's not like a bird you see flying tree to tree in your backyard. Those are small little birds that can go from place to place and they're really fast. This is a big bird. And Elijah's right, his wings are really big, but guess what he's flying on? He is flying on these warm thermals that are rising up off the land. That's why he can sit up there in the sky like that and just circle and not beat his wings at all. It's because he's riding these really, really warm thermals that are caused by the sun that are rising up into the air. Well, that should prove to you, if you looked at it and you saw your parents cook before and you saw the steam going up, that heat rises, right? It's lighter. It's lighter than cold air. So cold air sinks. Cold air is heavier than hot air. So this is what happens when you start to mix water with land, which is what we have the scenario here. We live in Wilmington. The ocean is right beside us. So when we go to the beach or we're sitting at home and we live in Leland or something, and you're sitting at home and you got the sun beating down on the land, all this heat is rising. Well, guess what? After all the heat rises, it leaves this gigantic empty space. There's nothing there anymore. So what wants to come and fill it in is cold air. Cold air wants to come and fill that spot in. Well, the water's always usually colder than the land in the summer. So what happens is that when the land loses all this heat and it leaves this big empty space, the colder temperature from the water comes and fills in for this space. And then we have something called a breeze start to blow. And that's what we're going to learn first is a land and a sea breeze. Why do they blow? Now, I didn't get really deep into it yet because we got to learn about temperature changes and why this is going on. But this is the basics of the wind. And this is basically how wind blows throughout the world. Hot and cold are mixing. Think about it. The equator, super duper hot. The North and the South Pole are super duper cold. Those two react and they make wind. And we have these gigantic wind belts on Earth. That's not just here in Wilmington. It goes all around the world. So I'm going to teach you all that too. But this is basically the recipe for wind. You got to have something hot and you got to have something cold to fill in from where the hot is. If you don't have an ocean beside you, somewhere like Kansas, if you lived in Kansas, the wind doesn't blow as much there as it does here because they don't have an ocean. You got to have a hot and cold mix in order for wind to work. Not unless a weather system's going over you and then the wind's going to blow either way. But listen, I'm going to go ahead and end this today. I'm going to give you questions on the clouds, and I'm going to give you just random questions on what the land and the water does as far as temperature goes and what makes the wind. I'm not going to give you anything about the recipe of wind yet. We're going to get into that later because it's a little bit tough. But listen, if you have any questions, please drop me a line. You guys know what my email is. You can Google message me on the classroom, and I'm going to be sending out my class, your assignments this week for when you start school back. Okay? Are there any questions? No questions? All right, beauty. I'm going to go ahead and end this. Oh, Aurelie, ¿qué pasa?
This question is something else. It's about the groups.
Yeah.
Going back to school.
Yes, ma'am. What about it?
I haven't gone.
Well, I'm going to send it today, Aurelie. Okay,
What?
and I'm going to send it not only to your parents, I'm going to send it to your email as well, so that you can get it twice. All right? So if your parents don't see it, you can tell them that it's in your email and you can check it. Does that sound good?
Okay.
All right. Well, look, guys, y'all have done a great job. I hope you have a great day, and we'll talk to you tomorrow. All right. See you. Well, actually, see you at 12 o'clock. Es su maestro favorito signing out. Adios.